This is really exciting to me. It's kind of opening up a new era of integrated food safety, and a lot of it is based on machine learning and artificial intelligence and food safety culture development.
Something to Chew On is a podcast devoted to the exploration and discussion of global food systems. It's produced by the Office of Research Development at Kansas State University. I'm Maureen Olevnik, Coordinator of Global Food Systems.
And I'm John Fabian. I'm a food scientist.
Hello, everybody, and welcome back to the K-State Global Food Systems podcast, Something to Chew On. The food we eat comes to us from a variety of sources, some through a complex international food chain, and some from our local farmers. Regardless of the source, the safety of that food is paramount in protecting the well-being of you, your family, your friends, or your customers. In this podcast, we speak with Dr. Randall Phebus, professor in the Department of Animal Science and Industry here at K-State. Randy specializes in food safety education and research, where his teaching and study spans most food categories. He works closely with food processors, regulators, and technology providers across the country, focusing on food safety process validation. Randy's research has taken him from the Biosecurity Research Institute at K-State, where to-scale food safety studies have been carried out on beef processing, to the study of bakery products in proving that the oven is an effective microbiological kill step.
Well, thank you so much for agreeing to do this. I've been wanting to get you on here for a while, and we've finally gotten around to doing it, and I'm looking forward to the discussion. Welcome, Randy.
It's great to be with you guys today.
I've had the opportunity of working with Randy for many, many years. Your focus is on food safety, and certainly you're known around the world for a lot of the work that you've done in that area. We'll look forward to learning more about the research and understanding where your focus is and how that information has been used. But I'd like to start out with getting a little bit of background on you, who you are, and what got you interested, got you started in the area of food safety, of microbiology, and all of the things that go along with that.
Well, to tell you what, the answer to that, it goes way back. My family, I'm from a little town in Tennessee called Waverly, and my father and mother have been in the grocery business since before I was born, which was before 1960. We'll leave it at that. And so I grew up in the retail side of the food industry with my parents working and owning the grocery store. And all through school and even college, I worked and supported that family business. But during that time, I also had a very keen interest, as a lot of young folks, in pursuing a degree in veterinary medicine. And that's what I went to the University of Tennessee to study. And after I got my undergraduate degree in animal sciences there at University of Tennessee, and with discussion with some of the close friends in the veterinary field that I worked with, I made the decision that really wasn't what I wanted to do. And just pure fortune, I was able to connect with a Kansan, Dr. Jim Riemann, who was a meat scientist specialist, a professor there at the University of Tennessee. And he convinced me in one meeting, basically, that food science, and particularly food safety, which is my area, would kind of be my calling. And so I was somewhat familiar with it just from my family heritage, but I really got into the food science and got my master's degree there at the University of Tennessee, and then stayed on for a PhD in food safety, which I got in December of 1992. And I actually came to K-State and began my assistant professor position here in food safety and in the animal science and industry department a month before I got my degree, my PhD degree, actually. So I was here in November of 92. And although I've had numerous opportunities to go to industry or even to go back to my home university over the years, I have chosen to stay at K-State, and I think pretty much I'm going to complete my long career here at K-State. So I'm in my 28th year as being a professor of food safety, and it's been a really dynamic ride, I guess we would say, to participate and watch how food safety has evolved and progressed across the globe, actually, in this last 3 decades is phenomenal. But then to look at where we are today and look what we're going to be doing in the future relative to public health and food safety, I think the next decade is just going to be off the charts in terms of what we have to do and can do to improve public health and food safety. So here at K-State, yes, I'm on a 70% research appointment, but I also, my 30% teaching appointment is just as exciting to me, where I'm mostly interacting with undergraduates. I teach the Introduction to Food Science course here, so I'm the person who gets the students coming into the food science program on their very first year. So I try to instill enthusiasm and excitement in those students and really help them get off to a good start in our food science program through that course.
And you do that really well.
Well, thank you, John. I appreciate that.
I'll step back and ask kind of a global question on where you on the work that you're doing these days. But what do you think are some of the most critical food safety issues in the food supply chain today?
Well, you know, we always, in food safety, we're always focused on those pathogens that continue over the last several, could be 100 years, causing us grief. Things like salmonella and E. coli and listeria, they're not going away. We've got data showing that in some cases they're expanding. So that is still the big focus, I guess, just from pure food safety. But as we sit back and watch what's happened just, over the last 4 months, COVID, it's not per se a food safety issue, or we don't think it is at this time, but you never know what's going to come down the pike. I mean, today you're working with salmonella, tomorrow you need to convert and work with a virus. You never know what's going to be on the agenda, even the next day, but particularly in the next couple of years out. And to me, that's exciting. You have to be adaptable and flexible and nimble to make sure that you can, address what is, the real focus point of any particular time in food safety. But looking ahead, I really think what's going to be exciting going forward, and hopefully we can even talk about that, is we are integrating other technologies at a very rapid rate into our food safety, traditional type food safety programs. So here I'm talking about machine learning and blockchain and artificial intelligence and all of these things that us microbiologists really didn't think much about in the past. We are now coming up with great ways, probably just scratching the surface, to make very good advancements that probably weren't thought about 10 years ago in terms of public health. So that's kind of what drives me in terms of excitement getting up every day is, I know a lot about salmonella. I don't know much about blockchain, but I do know that I'm going to get left in the dust if I don't learn, because it's going to happen. It is happening right now. So hopefully that answers your question. But, you never know. Today, it's the integrated dynamic aspects of things that, if we look at things like nanomaterials and their use in the food system, well, they have so many implications, whether it's food safety or nutrition or personnel safety of the people handling them. And so you can't just be any kind of one type of a scientist anymore. You got to kind of span or cross disciplines, which to me, I'm one of these people who's kind of like a sponge when it comes to wanting to get new knowledge every day. And whether that's in my field or outside of my field, that's what excites me.
Is there an issue, a potential problem that you think that academic scientists or industrial food science are missing, or they're ignoring, or they're not wanting to face? I mean, are we kidding ourselves in some cases, or just ignorant?
Well, that's probably always going to be the case. Try to take the optimistic approach to most things. We've got all the hurdles that are always there in terms, particularly in academia, of finding out and learning who's doing what, whether it's on campus or out in the industry or in another country, it doesn't matter. But breaking down those silos and those information barriers, that to me is where we continue to have difficulty, even as much as we try to go interdisciplinary and transdisciplinary in our approaches to solving problems. I think we're making progress, but we still have a lot to do there. And, that's one of the things that's always, even before Maureen came to campus, was exciting to me about our K-State Global Food Systems program is that's the goal, is to get people out of their box and to get them talking across disciplines so that we can bring new tools or new remedies to the table in an applied way, not just dream them up, but actually get them to work.
Do you think the university, and this is a loaded question, so are there roadblocks that the university has to that interaction, or particularly to that interaction that might drive grant or contract reception to the faculty?
Well, that is kind of a difficult question, and honestly, I haven't thought so much about it as a focused thought process, but, just being here so long, John, you're one of the few people been here longer than me, I think. So you kind of pick up on what some of those barriers are to make this happen. And yes, we have differences in ways we approach things or rules and whatnot across different colleges, or if we're working at, for instance, the Biosecurity Research Institute, which is where I do a lot of my work. Sometimes I value that facility like crazy because I can do work that nobody else in the world can do at scale in that facility, including things like COVID. But, some of the barriers to getting in there and doing work efficiently and making it, there's not enough hours in the day to do all the paperwork and the IBC approvals and the IRB approvals and the biosafety training. And I just think all of those things are important, but we need to find ways to maximize the efficiency and take out some of the redundancy.
Yeah, and I think intellectual property has become an important factor, or in some cases almost a holy grail, and that certainly slows the process down in getting that resolved. If in fact we can get it resolved between an industry funder and a university doer or recipient.
All of that intellectual property and everything, really the root of all of that discussion is our budgets. We continue to have budget issues. They're increasing as we're on the phone here. But to me, a lot of what I just went through in that list, for instance, training I've got a big staff, a lab staff, and to have them trained and medically cleared through Via Christi here in town, and some trainings, and we've probably got 20 modules we have to go through each person each year. And I have to pay for that. And really, there's not many budgets that you can cover all of that with, not even to mention the managing of all of that. So I've always been looking, just outside of the scope of science in my research program, but how can I do things more efficiently so that I'm not trying to do the paperwork as much as I am doing the pipetting and spreading plates and generating data. That's what my passion is,
Right.
Randy, you were a recipient of a pretty major grant over the last couple of years. Can you talk a bit about that? You mentioned BRI and the capabilities that you have there, and I think that grant opportunity took you into the facility. Can you give us a bit of background on what that was and maybe some of the outcomes?
Absolutely. Even in my career, that has been a defining program that we got we submitted it in 2011 and were awarded the grant in 2012 through the U.S. Department of Agriculture's NIFA program, National Institute of Food and Agriculture. And we were the recipient of what's called a CAP grant, which is Coordinated Agricultural Projects Grant. And that grant was $25 million over a 5-year duration, and it was multi-institutional. I think we ended up with 17 different institutions and 2 or 3 different agencies, government agencies, working under that grant. There was 5 of us that managed it on a daily basis. The grant, with 2 no-cost extensions, turned into a 7-year effort. And K-State was extraordinarily important in the overall $25 million grant. We brought about a little over $9 million to K-State directly of the funding, which we were by far the largest recipient of the subcontract out of that grant. And it was focused on understanding and controlling shigotoxigenic E. coli across the entire beef system. So here we're talking about cattle production, water and environmental management, beef processing particularly, and then all of the things that happen as far as training the next generation of food safety specialists and doing teacher education in our K through 12. So it spanned everything you can imagine. Boy, I tell you what, I was tired at the end of it. It just ended in December of this past year. But to see what we accomplished in terms of working with the industry, it wasn't just us academics, even the beef industry was majorly involved, letting us work in their facilities, helping us teach, serving on advisory boards, and it was just a very big public-private partnership effort. And, you know, we gained an understanding through all of this at a level that probably wouldn't have happened with your normal granting process of, say, you know, a couple $100,000 to this project and to that project. To be able to pull all that government funding together, pull the team together, and make them work together toward defined goals really was efficient. I don't think you're going to see any more of the CAP grants at the level of $25 million per project anymore. They've indicated that's probably not going to happen. But the concept of getting people, you know, interdisciplinary type people working together toward a common set of objectives really did work. And so right now, you know, we've published manuscripts, and probably 100 grad students are out there working in the industry out of the project. So I think, you know, over the years, you're going to see substantial evidence of the importance and the work output that grant generated for food safety, particularly beef safety in this country.
That's incredible. You know, yeah. I think the everyday listener knows about E. coli, but the other half of that name of that bug is probably unfamiliar to them.
Yeah.
Why is that a big deal?
Well, that's a great point. Everybody in school hears about E. coli. It's on the news all the time. And it is generally a, you know, very beneficial, required, healthy organism for our GI tract. It's the most common organism in our GI tract. But there is a subset of E. coli that is what we refer to as shigotoxigenic E. coli. It means they produce a toxin that's similar to the toxin that Shigella dysenteriae produces. That's the organism that causes dysentery all around the world. And it's extremely potent, can be extremely deadly, knocks out your kidneys, and particularly in young adolescent type people, causes hemolytic uremic syndrome and bloody diarrhea. We also refer to this group, I'm not getting into too much science here, but we call them enterohemorrhagic, which means that they produce bloody diarrhea. So it's a major issue, and it's been around particularly related to the beef industry for quite some time now, since about 1992, when we had Jack in the Box outbreak, and kind of made its rise to fame during that time. Even during that time, K-State and my group was extremely focused on controlling shigotoxigenic E. coli, worked with Cargill and Frigoscandia, and we developed here at K-State the steam pasteurization process that very large percentage of the U.S. beef processors adopted and installed these big steam cabinets for major manufacturing food safety in the beef industry.
I remember that.
Yeah. That organism, you know, continues to cause problems. We talked about it in beef, but as far as manure and water runoff from feedlots and dust and things like that, we have problems with fresh produce, whether it's leafy greens or sprouts or whatever it might be. That organism, you know, crosses several different food commodities. We've had problems with it in wheat, which is then transferred to raw flour coming out of your area, John. And that's one area that I'm working on right now is working with the industry to develop interventions to kill or control shigotoxigenic E. coli and salmonella in flour and baked goods. So, you know, you can't just focus on one commodity. These organisms span the gamut, basically, melons and peppers and spices and all kinds of things.
Yeah, we've certainly seen recalls in all of those areas over the years.
Yes.
Based on those organisms. Yep.
And I might add that it's not just human food. We're doing these same scientific research validation projects, we call them, for pet foods. And pet foods now under the Food Safety Modernization Act are basically regulated to the same standards as human foods. And so they have to have those validated processes in place, which is kind of my specialty, is validating commercial manufacturing processes for their ability to control these organisms. So we've been doing almost as much pet food work as we have been human food work here at K-State for the last few years.
It's a huge business that a lot of people don't know anything about.
Well, that's true. And here in Kansas, we have all of the agriculture and the meat processing. So that means we have a lot of byproducts that go into the pet foods.
Yes.
So if you look at the pet food industry here in Kansas and Missouri especially, we are probably the biggest in the nation. So it is a huge issue for our state.
Manhattan was chosen several years ago as the new home for the National Bio and Agro Defense Facility, but the MBAF is what we call it. Will there be an intersection with the kinds of work you're doing and that facility? That's not, I know, directly associated with the university, but it's certainly physically directly associated with the university and very, very close to the other laboratories you've worked in. What kind of communication and overlap do you see with that facility once it's completed?
Well, I think it's going to be a tremendous positive impact on our community and our region, not just our community, but our region, but especially Kansas State University, because what's really going to happen, I think, is we're going to have a lot of opportunities for scientists, particularly the vet, animal, oriented type scientists, to work with the NBAF government scientists. And I really think it will spawn a lot of innovation. And particularly, like for me, I do a lot of applied research, which means I'm taking technologies, maybe they were already developed by the technology industry, but they need to be either adapted or validated for the food industry. And so I take those, and I'm not necessarily developing the technology, I am proving its effectiveness. And a lot of times that's either done here at Call Hall or over in the BRI. So that's applied research, but I think NBAF will help with a lot of basic research interactions where, we're understanding the molecular side of things or generating physiological responses to vaccines and things like that. And, that'll strengthen both the government program and the K-State program, us working together. In terms of food manufacturing, food processing, I don't think there's a major connection there. Per se, that you immediately see, I guess, because it's mostly animal health and foreign animal disease control type focus. If we take COVID as an example, NBAF and DOD and all of them understand that is a threat to our national security, and they are interested in helping, and whether COVID turns out to be a food safety risk or impacts the food chain or whatever else, it has something to do with national security. We do have right now in existence, as the NBAF is being built, there are some transition funds that the government has provided to kind of foster the work and the interconnection with K-State as that building is being built. I see that as being really big because it helps us leverage additional funding when we go after other, government funds. For instance, a group of us just submitted a USDA NIFA grant we're waiting to hear back from on controlling COVID in meat and poultry processing. Well, the NBAF Transition Fund was very valuable in saying, we can leverage this amount of money toward your grant if you get it, to improve what you do, to get more out of the government funding. So that's kind of where I hate to say play the game, but it's play the process of pulling money together, opportunities and resources together from across different groups so that we can do better, more complex, more integrated projects and do them quickly and get data out there. Obviously, we need to know how to control COVID in meat and poultry processing where it's such an issue right now.
Yep. Let me just skip back. You used the term validation, or when you to validate a process.
Mm-hmm.
What does that mean in the real world?
In the real world, it's actually a process that's mandated. It began back in 1994 when HACCP, Hazard Analysis and Critical Control Points, was mandated for manufacturing of meat and poultry products, which is a science-based system where you actually have to understand your process and demonstrate that it is capable of controlling whatever food safety hazard is related to your product. And then there's a kind of a connected term called verification. So you got validation, which is scientifically proving the capability of a process. And then verification means that on an ongoing basis, you are proving that your system is working the way it was validated. So they go hand in hand. So HACCP was mostly for seafood and meat and poultry. But now with the Food Safety Modernization Act, it basically brings that same risk-based, scientifically based mindset to preventive controls that HACCP did. So now we're basically doing that approach across all of the food categories. And so validation means specifically that I go in and I will, under our biocontainment facilities and operations, I will actually inoculate the food product with the organism of interest. And then I will apply whatever technology we're interested in and quantify the impacts of that in terms of reducing the level of that organism. Generally, we try to, depending on what part of the process, if it's an animal harvest situation, like a carcass wash, we would like to see 2 to 3 logs, which would be 99.9% reduction of what we put on there as far as reducing that particular pathogen. If we're doing maybe subprimals like loins or roasts, which wouldn't have very much on it by the time it gets to that point, if we could show 1 log reduction, that's a major advance. That would be 90% reduction. So again, that kind of tells you it's not just one point in the process that we try to control this. It's at multiple points and kind of having an additive effect of microbial protection throughout the whole process. And, that whole process includes restaurants and consumers. They're just as important in the food safety chain as the manufacturers are. So that's kind of how we operate, looking at the systemic reduction that we can get when we mimic a full production process. And not many universities can do that, but with our BRI facility, we can follow all the way from a live animal through harvest, through fabrication, through manufacturing of hot dogs, and hook it all together under one roof.
Excellent. If I remember, HACCP grew originally out of the U.S. space program, I think.
Yeah, that's correct. It was actually invented by the Pillsbury company back in the early days of NASA to ensure that none of the food that the astronauts would be consuming would make them sick. I teach this in my Intro to Food Science course, and I try to keep people laughing a little bit, but can you imagine being in your spacesuit and having diarrhea or throwing up? That would be kind of a mess. It would be deadly. And so HACCP it's predictive management, basically. You are anticipating what could happen and then instituting controls to make sure it doesn't happen.
Significant difference in approach to what a lot of people think.
Yeah.
All right.
You talked about the criticality of interdisciplinary research and, the need to understand things that are outside of your current area of expertise. And you've also talked about NBAF providing some basic research in some of these areas. We've got several departments on campus that really just focus on basic research, whether it's physics or biology or chemistry or some of these. How do you see these groups? How do you see the intersection between interdisciplinary and the fundamental sciences on campus and the need for that kind of interaction from the basic research perspective?
Well, that is exactly the point I was trying to make. And Maureen, as the manager of our Global Food Systems program, I'm looking for you to make that happen. A lot of the technologies that we are dealing with in food safety today, particularly what we call intervention technologies, those like carcass washing or cooking or whatever else, the way the industry and consumer preferences are, everything's going to minimal processing or clean labels where you don't use preservatives or chemicals, ingredients in the product. And yeah, that may appease people who are looking for all natural and things like that. But, from a scientific standpoint, it can cause challenges in terms of food safety and shelf life and food quality. And so as we look to develop these technologies, for instance, high pressure technology, which just applies, high 80,000 PSI per square centimeter to a product, it kills the organism. I need someone like in our physics department or in our engineering department to figure out how to make that technology work in a high-paced food production scenario. So, that's where we team up. And I heard some other podcasts that you've done, and just knowing who is on campus doing what, or even who has an interest in doing something, is where our Global Food Systems program can really help. I just found out, and we actually was able to get an internal grant recently on controlling organisms in wheat. And a part of that grant was rapid detection of the organism based on using these extremely one atom thin layers of graphene. Well, until we had the Global Food Systems program, I really didn't know we had someone on campus looking at that, and so we were able to hook up and get a seed grant, and as soon as we get our labs open back up this week, we're going to be, addressing that. So to make the answer a little bit shorter is we need engineering, we need the basic sciences, mathematicians, IT people, big data people to partner up with us microbiologists and, predictive model people and actually pull it together and address the food system, not, say, the automobile system, that sort of thing. Can I just point one thing out that happened this week that I think is going to be really important for the future of food safety in the U.S. and probably the world, but starting here in the U.S. is the Food and Drug Administration just released their what they call blueprint. That the title is The New Era of Smarter Food Safety. It's a blueprint that the FDA is going to follow that really takes us into the next decade of food safety. And particularly they point out 4 pillars of things that they're going to address, but it basically comes down to advancing technologies, managing things that we haven't managed before to any degree, which is the food supply chain. And looking at how we document and digitize the food supply chain so that instead of doing a trace back because of an illness that's going to take, 3 months, we can do it in 3 minutes based on big data and blockchain technology and those sorts of things. Right. And then a piece of that is food safety culture. We can have the world's most wonderful technologies in place, but if we have a cook or a person working on the processing line that when the supervisor's not looking, they cut corners, then we're always going to be at risk. And so developing a culture where that doesn't happen is part of it. And, this is coming out of the FDA, but one of my very close friends over many years, Mr. Frank Giannis, is the Deputy Director of the Food and Drug Administration. He was formerly at Walmart and before that at Walt Disney World, running their food safety programs. And this is really exciting to me. It's kind of opening up a new era of integrated food safety, and a lot of it is based on machine learning and artificial intelligence and food safety culture development. So, what we're doing here at K-State, the reason I get so excited is right in line with what the FDA blueprint is calling for. And as long as we, continue to develop that and formalize it and get more people involved with it, including more students, then we're going to be leading the way, I think, here at K-State, or one of the institutions that leads the way.
I listened to Frank Giannis's presentation at the virtual IFT meeting. He certainly covered exactly the topics that you mentioned, and he's been working on those topics for some years, I think even before he got to FDA. So it's interesting to see how some of that is starting to play in. And interestingly enough, the last blockchain series that I attended at K-State was in the business department. So again, the interdisciplinary approach to things is critical, and connecting you all and getting those discussions going along is going to be a fun challenge over the next years. But there's a lot to be done.
I just really appreciate you guys doing these podcasts and getting our messages out and instilling some interest in the public, whether it's our students or whether that's other people around the country listening to our podcast. So I encourage you to keep it up.
If you have any questions or comments you would like to share, check out our website at ksu.edu/research/global food and drop us an email. Our music was adapted from Wayne Gowen's album, Chronicles of Carmela. Special thanks to him for providing that to us. Something to Chew On is produced by the Office of Research Development at Kansas State University.